Hello, my name is Anna Vilanova, and it's my pleasure to present you ComVis-Sail, a comparative sailing performance visualization for coaching. This work was developed for Pieras, who was a PhD student at the Computer Graphics and Visualization Group at Delft University of Technology. This is work in collaboration with Ricardo Marroquim, Douwe Broekens, Eisemann, and myself, who I'm currently at the Eindhoven University of Technology in the visualization cluster. We also collaborated with the Proeftuin of the North Sea, the Sailing Innovation Center, and the Watersportsverbond. So sailing is actually a very complex sport, basically because many factors has an influence on the performance of the boats and the sailors. So the weather is very important, but also of course, the handling and managing of the boat, and the weather can change locally. And often it's very difficult to find a relation between the actions taken by the sailors and whether a boat is winning or not. So a way to try to improve this evaluation of the performance of the boat and the sailors, one option that has been implemented is to add actually sensors to the boat to see how is the maneuvering of the boat. So sensors like GPS, which encode position and help you to encode speed, but also inertia measurement units, which allow you to encode different rotation angles like the heel and the pitch, and also the course over ground, which are illustrated here in the slide. There are also a sensor that can be put on the sail because, of course, how the sail behaves is important. This sensor measures the clue, which gives an information about the loading of the sail. So if there is a low deformation, usually there is a high clue, and if there is a high deformation of the sail, the clue seems to be commonly low. A final sensor that is used in the boats is for the rudder. So the rudder indicates how the orientation of the boat is being changed through the race or through the trajectory. So in a training, a common practice is to use what is called the lineup session, which is two boats are sailing in a straight line. So you ask them to go to a point and sail in a straight line, and a coach boat is behind and is looking at how the boats are behaving. So the idea of these lineup trainings is that by the fact that you have two boats and just moving in a straight line, you are putting as constant some of these complex factors that influence the performance. One of them is the weather, which you assume is more or less the same for both boats, also the currents and the wind. Another factor then that you can evaluate is the boat handling, and there is where the maneuvers can be captured, you expect, by the sensors. And finally, it might be that you have two different boat configurations, such that you can also evaluate how good is the matching between the sailor and the boat's configuration. So these sensors are set, and what happens is that you get information like the one I'm showing here, multiple variables that change through time. And are represented in these line graphs. So then the coaches are looking at these line graphs and try to identify what are the characteristics that make one boat, for example, reach the goal faster than another, and what were the handlings that allowed that. That's the goal actually on looking at the data, and also the the coach wants to be able to then evaluate what could instructions to give to the sailor to improve their performance. However, this data is highly heterogeneous, so they represent different things like the angle or the force in the load of the sails. They are multidimensional, so it's difficult to understand the relation between them, and also they are time varying, and there are causal effects in the data. So analyzing directly the line charts like they are usually presented is a very hard task for the coach. So often what is being done is they summarize the information just to the averages, and that's what they are comparing. But this summarization is often too rough to take import relevant conclusions. So in our work, we present ComVis-Sail, and we try to design a visual analysis tool that helps coaches analyzing this type of data. And the main questions that the coaches have is when and why a boat performs better than another, so goes faster or reaches faster the goal. So this can be divided in 3 different tasks. One is discovering which segments are interesting, right? In which places of the lineup, training session, there were interesting events taking place. Compare the variables information between themselves, and also compare the variable information through time between the boats. So ComVis-Sail is a dashboard. This is the end result of it, which has multiple components. So we have components that have to do with the spatial information and the trajectory that the boats are taking. Some information that has to do with the handling of the boat and summarizing for periods of time or for the trajectory. And finally, the temporal information is, of course, also relevant. So we have also visualizations to help to clarify what is the temporal behavior of the boats. One very central factor in our design is actually the glyph. So as I mentioned before, looking at the line charts makes it very difficult for the coaches to analyze, also because these line charts and the semantic meaning they have is very far away. So designing glyphs that help to understand the data is what we try to approach this challenge. So we did glyph design for 2 main aspects. So one is to show the multivariate information at an instant point. So then you see how the relation between variables are in an intuitive manner, or trying to make it intuitive. And then you also want to be able to summarize periods of time. And for that, we also design a summary glyph. For the design, we explored different options. So one was a metaphor inspired by the horizon equipment that is in a plane that also helps to orient the pitch and the heel of the plane. So we know that if it is in an horizontal line in the middle, then it's a steady or a balanced performance of the boat, and having a pitch and a heel then generates angle or going up and down with a line. We altered a bit the direct metaphor such that the pitch and a heel could be evaluated separately, which is interesting to the coaches and sailors, because using directly the metaphor makes it difficult to evaluate the heel, for example, when the pitch is very high. Another metaphor we used is looking at the boat from the top. So you look at the boat from a camera that is situated at the top and look at the behavior of the mast. And this gives you an indication of where is the pitch and the heel. And we represented that as a point and a line that represents this mast. For the representation of the clue, we use 2 main metaphors. One is about force, because clue measures actually force, so deforming in the idea of that you are deforming also the sail, but also we encode it in rotation of the sail. So given this basic design, we also added the rudder, which is rather simple, which is based on simulates how the rudder is actually located in the boat and has angle as the encoding. We represent a boat also to give semantic meaning and intuitive representation to the sailors and coaches. So we have the instance glyph, and then we extended that to represent a summary, which shows the distribution of the values on the different elements as a kind of histogram represented with bin elements and different layered values. For the mast, we used density-based scatter plot. So to be able to decide whether the glyph design was adequate and which glyph design we should choose between the mast and the horizon, or also whether the sail should be the sail or the force, we made a user evaluation in which we evaluated based on different tasks and their performance on getting the right values. And we did different aspects. So one is the individual assessment of the glyph itself. So how good a user is able to identify the values themselves. Also, we evaluated the summary glyph about the distributions, whether the distributions were recognized, and also one of the tasks is about comparison. So how easy it was to compare the glyphs and how easy it was to detect differences between the glyphs. So in this evaluation, some results came out. So for example, we can see, this is an example of the experiments. You can see in blue is the expected value that the user should give, and the orange gives what the users actually estimated that it could be. And we can see, if you look at the mast, that there is a kind of bias in some direction when it goes into the pitch. Well, this bias is not so present. It's not present actually in the horizon glyph. This is confirmed when we use a cumulative error analysis. We clearly see that pitch has a bias. So the results of this evaluation gave that there is a slight preference for the horizon glyph based on the bias, but also on the preference of the users themselves. There is a strong preference for the sail design to represent the clue. And for the summary glyph, the mast design is able to show the correlation between the variables, but actually the sailors and the coaches didn't identify them as being very relevant for the tasks they were wanting to perform. So at the end of the evaluation, the pitch and hill representations were very similar in results between the hill, between the mast and the horizon, but we opted to go for the horizon glyph as a default, and still the mast is possible as an option if the users are interested. We use the glyphs in the temporal view of the boat handling, so to show more intuitively what are the values through time, a part of showing them in a heat map to make comparison. And also we use the summary glyphs to encode periods of time that can be defined by the user. The glyphs are also used, as I said before, to make comparisons between the boats in intervals of time or through the whole session, and then they can evaluate the mode of the range of the values that have been used in the two boats to take conclusions. And one important aspect is also that the semantic encoding helps to analyze the data. For the sailors, the trajectory itself is also relevant, although in this lineup exercises, they are mainly straight lines, but you are interested in seeing which of the boats is going ahead. However, in this kind of competitions in a boat, who is winning or who is ahead is not easy to define. So it depends on the line you trace, right? So in this case, it would the blue boat is winning all the time, but if the line is different, actually the yellow boat is overtaking the blue boat at some point. So often the lines are traced according to the wind, and in order to do that and to facilitate the analysis to the users, what we do is we connect the trajectory such that the temporal aspect of the positioning is clear. The orientation of the lineup is based on the wind direction, because that's often the direction that the coaches and the sailors want to look at to identify who is going ahead. And we also directly encode the information based on the line of the wind to identify more easily for the coaches which one of the boats is actually ahead. And we also encode the speed. So we managed to then design the dashboard. This dashboard has many interactions that are allowing to analyze the data and go in detail in aspects that are interesting to the user. So this a very important aspect of the dashboard is actually the interaction between the different components of the views and the data to be able to get conclusions. So at the end, to be able to evaluate how good our dashboard is working, we had multiple phases of user studies in which we analyze the full dashboard. For this type of analysis, we use two coaches that are using this type of sensor data in their training. I want to highlight that this is not common practice, so it's not easy to find many coaches that are using these sensors, and also sailors that work under these sensors, with boats having these sensors. So we had an initial prototype that I didn't show, but that it was used very much at the beginning to actually try to understand what are the situation of when the coaches and the sailors are analyzing the data. We regarding many aspects of this initial dashboard. Then in the other sessions, we use coaches that were not involved in the design itself of the dashboard. I want to highlight that. So then we have two sessions in which, in the first one, we have we analyze the lines ups of their own data. The coaches do this analysis while we were with them, and we ask questions through the session to understand their mental reasoning. And at the end, there was a qualitative questionnaire. There were two sessions on this direction, and then we have another phase in where there were three sessions where done during trainings, during this lineup trainings with the data of the training itself, and then the tool was used during the debriefing of the training sessions. So things that we learned by it is that the dashboard actually helps to analyze the hypothesis that the coaches had during the lineup sessions and to understand how the boat performance behaved. We realized that coaches often altered the workflow. They were using the dashboard in workflows that originally we didn't think of, and they did that based on the needs they had. The glyph metaphor that was used was easy to understand for the coaches and also for the sailors. So it was a good tool for them to understand the multivariate information. We realized that when they were analyzing the summary glyphs of the distributions of the different variables, they were more interested in the overall shape of the distributions rather than exact values or absolute values of the positions. The correlation between the variables themselves was interesting to them, and they tried to analyze them through the parallel coordinates plots, but this turned out to be rather challenging for them to do. They managed in some situations, but it was challenging. And in the trajectory view, we realize also that they simplify the color encodings to who is ahead and who is behind, or whether they are tight, rather than looking also at the shapes. So as a conclusion, ComVis-Sail is a visual analysis tool for coaches and sailors to analyze training performance and boat performance. The glyphs, the instant and the summary glyph design were central to this dashboard, and they proved to be useful for the analysis. And our evaluation showed the potential of the dashboard actually to be used during the trainings. For future work, it would be interesting to analyze not just one lineup, but multiple lineups of the same session, because it helps to generalize also in the conclusions they are taking. As we said, the coaches mentioned that they find it useful, or we realized that it was used to communicate to the sailors, although this was not the original goal of our dashboard, and that's why the design is not adequate for that. It will be interesting to analyze that in the future work. And further, similar concepts to what we have been using for the sailing problem could be also used in other racing disciplines. With that, I want to thank you all for your attention.